Question 4e, when concentrated sulfuric acid is added to water, we have dissociation taking place in two stages. The question is, explain this observation. So explain an observation why the sulfuric acid, which is of this concentration, has a pH of 0.96. It isn't explicitly clear what the examiners are looking for in this question, if I'm perfectly honest. So this type of question, it's practice to try and see what the question is actually asking. The first thing that I would notice, and I would note in my question response, is that stage 1 is full dissociation and stage 2 is a partial dissociation. This is a strong acid, this is a weak acid. So what we're trying to do here is explain why the pH is 0.96 and explain how that proves, if you like, that we have two dissociations, one of which is potentially strong and one of which is potentially weak. Now, the way that I would approach this is, if both of the dissociations were strong, that would mean I would have absolute complete dissociation. If I had absolute and complete dissociation, then the quantity of hydrogen ions that I release would be double that of the sulfuric acid that I had to begin with. So if I have a concentration of 0.1 mole per decimeter cubed sulfuric acid, I'm going to have a concentration of hydrogen ions which is twice that, so 0.2 moles per decimeter cubed, i.e. 2 lots of 0.1. If I did have a hydrogen ion concentration of 0.2 moles per decimeter cubed, then that would give me a pH of 0.7. This isn't true. When we look at it, we can see the pH is 0.96. So the only solution to that, or the only way to sort of figure out why this isn't true, is that we must have at least one of the stages being a partial dissociation. So this is all because sulfuric acid is dibasic and therefore has two protons that can be released. So what are we actually stating? We're stating that if we had a concentration of hydrogen ions that was due to full dissociation at two stages, the pH would be 0.7. The pH is not 0.7. It doesn't agree with the pH that's been quoted, and therefore that indicates and proves that we have potentially a full dissociation and a partial dissociation as a consequence of that. So that's how you pick up your 3 marks there. One for talking about your two dissociations, the other one for discussing the dissociations, and the third one for giving a calculation to prove, if you like, what is happening. The next question, a student adds an excess of aqueous sodium carbonate to dilute sulfuric acid. Predict what the student would observe. Remember from the earlier questions, observe is what you see, what you feel happening. Explain what happens to the equilibrium in stage 2 as the aqueous sodium carbonate is added. Right, we've got a carbonate and we are reacting it with an acid. Acid plus carbonate means that we have production of a gas. So we're going to see fizzing, we're going to see bubbling, we're going to see effervescence. Any of those words would be acceptable. Now we're looking at the stage 2. So this is the equation to represent stage 2. HSO4- is dissociating to release the H plus ions and the SO42- ion. Now the carbonate that we add from the aqueous sodium carbonate is going to react with the hydrogen ions. So effectively what the carbonate ion is doing is removing hydrogen ions. And if hydrogen ions are being removed, then what will happen, thinking about Le Chatelier's principle, is that the HSO4- will seek to restore the H plus that has been removed, and therefore you will need for your forward reaction to increase slightly and temporarily, which means that the equilibrium is going to shift slightly towards the right hand side, and so we'll have an increase in the yield of products on that side, which is what we want in order to replace the H plus that we have just removed.